Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Transformers Architecture. The master brain behind modern AI, understanding the building blocks of powerful LLMs. Imagine you're building a super smart assistant that can write stories, answer complex questions, and even code. How does it understand all your words and respond so intelligently? The secret sauce is a revolutionary AI architecture called Transformers. Think of Transformers as the master brain that allows modern AI, especially the famous large language models, LLMs, like ChatGPT, to process massive amounts of information and understand context like never before. It's the engine powering the AI revolution we're experiencing today. Before Transformers, AI models struggled with understanding long sentences or conversations. They were a bit like a student who can only remember the last few words you said, forgetting the beginning of your sentence. This made it hard for them to grasp the full meaning or context. For developers, this meant building complex systems that couldn't truly understand human language globally. We needed a way for AI to pay attention to asterisk all the important parts of a sentence, no matter how long. This is where attention comes in, the core idea behind Transformers. Instead of just reading words one by one, an attention mechanism lets the AI model decide which words are most important for understanding each other word in a sentence. Think of it like reading a complex article. You don't just read linearly. You highlight key phrases, connect ideas, and mentally link related concepts across paragraphs. Attention allows the AI to highlight and link words to build a richer understanding of context. A transformer model typically has two main sections, an encoder and a decoder. Encoder takes your input, like a sentence, and turns it into a rich, deep understanding, a bit like an expert translator first fully understanding of foreign sentences, meaning and nuances. It processes all words simultaneously, capturing their relationships using attention. Decoder takes that deep understanding from the encoder and generates the output, like a response or a new sentence. It's like the translator then carefully crafting the perfect response in the target language. This structure allows transformers to handle tasks like translation, summarization, and generating new text. The encoder isn't just one block. It's made of several identical layers stacked on top of each other. Each layer has two main sublayers. 1. Multi-head attention. This is where the magic happens. Instead of just one attention mechanism, it has several heads working in parallel. Imagine a team of experts, each focusing on a different aspect of the same problem. One head might focus on verbs, another on nouns, another on sentiment. This gives the model a much richer, multifaceted understanding of the input. 2. Feed-forward network. After attention, a simple neural network further processes the information, refining the understanding before passing it to the next layer. This helps the model learn complex patterns. The decoder also has similar layers, but with crucial additions and modifications for generating output. 1. Masked multi-head attention. When the decoder generates a sentence, it predicts one word at a time. This masked attention prevents it from cheating by looking at future words it hasn't generated yet. It only pays attention to words it has already produced. 2. Encoder-decoder attention. This is a new attention layer that allows the decoder to look back at the encoder's deep understanding of the original input. This ensures the generated output is relevant and consistent with the input context. 3. Feed-forward network. Similar to the encoder, this refines the output before the final word prediction. A core challenge for transformers is that they process all words simultaneously. not one after another. So, how do they know which word comes first or last in a sentence? This is where positional encoding comes in. It's like adding a small, unique GPS coordinate to each word, indicating its position in the sequence. These aren't just simple numbers. They're clever mathematical patterns that tell the model the relative position of each word, allowing it to understand syntax and order without sacrificing its parallel processing power. By combining attention, the encoder-decoder structure, or just encoders for models like BERT, or just decoders for models like GPT, and positional encoding, transformers overcome the limitations of previous AI models. This architecture allows them to process vast amounts of text data, learn intricate language patterns, and understand context over extremely long sequences. This is exactly what makes large language models, LLMs, so powerful and capable of complex tasks like writing coherent essays, generating code, and holding nuanced conversations. As developers, understanding this foundation opens doors to building incredible AI applications. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.